Hello, welcome back to the channel. Today I'll show you how to design an easy M1 system. There's actually a ton of stuff that go into making an M1 work in order to be organized, since I'm going to be creating a full combat system by the end of this series. But for now, we're only going to focus on the top part here, and these parts won't be getting a full tutorial on. So to begin, first we need to detect our left click. And we will detect that by this local script here. That is the whole purpose, is to read inputs. Once it reads an input, it sends it to a remote event, and the server processes the input, finds which player sent it, and then each player has their own process input server script, because there's a local scripts is every person has their own local script, so every player will have their own server script to process that local script. And once it processes the input, it will send it to this module script, which contains all the class information. And the reason I chose to store the class in a module script is so if I want to have multiple people use the same class, I just have to use this singular module script, and they'll use the class that they want. And you can make NPCs attack too, which is why using a module script is a highly recommended practice. To explain how M1 logic works, we split the M1s into stages. Because I have 4 M1s, that means I need 5 stages. 4 stages for each different variation of the M1, and the last stage is so I can't M1. If you reach the last stage of the M1 after you use your last M1, then it will just reset back to 0. So this is how it works. If the condition is met, then we move on to the next stage, represented by these green arrows. However, if we fail the condition, then we just go back to state 0, where we just use the first version of our M1 again. And the condition for using the green arrow is if you M1 quick enough. And in our case, it will be 0.4 seconds. If you M1 in 0.4 seconds, then you use the next stage of your M1. And finally, the last piece that we need is to rig our players and rig this dummy. And since we're only using M1, the only thing you need to put inside of your starter character scripts is stun, this thing right here. If you don't know what starter character scripts does, basically whatever you put inside here, whenever you respawn, it will also put it inside of your character. Iframes, mechanics, style. If I respawn, even though this model gets deleted, my new one will still have it. And for this video, only put stun in here, since stun is the only thing you need. And make a dummy, and also put the stun thing inside of the dummy. Now it's time to finally show off the scripts. So here I have the input recognition thing, and since this is already pre-built, like the entire combat system, this is the table of all the inputs I'll be using for the rest of the series. And this over here, for now, all you need to worry about is the M1 input. And the cool thing about this table actually is I got this from ChatGPT when I just told it to give me a table of all the inputs. And I didn't know that you can have tables in tables. Like, you can have dot properties inside of all the tables. So when you check for if a table exists using this line right here, it just finds their existence easily, and you can use that to really optimize your code when you're making a giant table and checking which input you press. But for now, you only need to check for the M1, which I've already put here instead of ability. Normally it'd be ability. And now it will go here, the server will process it, and it will check the player, find its class, which I stored in here. But in this example, you don't need a class. You can just send the signal to the module script immediately. And now we have the module script right here. Sorry, I left this out. And first, we have the input process function right here. And since we're only doing an M1, it only processes the M1 input. If we needed another input, we would just put in input equal corresponding string like D, and then blah 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 blah, but we're not doing that in this video. And this is the state logic I was talking about. And before we start the state logic, I have this check right here, which checks if the player is stunned. And this is important because we need to stun the player when they're M1ing, or else they're going to start move stacking if they master M1s. And this right here is the logic for the state functions after you clear the stun check. So since all the red arrows point back to stage 0, I just check if the stage 0 condition is met, since it's the same for the rest. And the rest of these if statements are for moving up a stage and doing the corresponding M1 for each stage. And each of these empty functions right here are supposed to be each stage of the M1s. Alright, now it's time for the stun logic. And I don't use no timers, I use timestamps because it's the most efficient method that I know. So how this works is there's a function called os.clock, and what this function does, or method, is it returns the amount of time since the server started. That's how people get those server H timers. And what this allows you to do is, instead of setting a timer which just devours resources, since it's an equivalent of a for loop, we have say, let's say I get stunned 9 seconds since the server started, and I tried to perform an action at 11 seconds. obviously, since only 2 seconds have passed, I should still be stunned. So I do this math where inside of this module script, it will subtract 11 minus 9 seconds, and it will equal 2. And then it will find my stun time, which is 4 seconds, and check if that difference is bigger than 4. And since it isn't bigger, that means I'm still stunned, and it won't let me do whatever I was trying to do since I was stunned. And now here's the module script that contains the is stunned check. So I store all the previous stun, like when was the player stunned, inside of this table right here, and I pass the character or the model's name to index them. And for how long they should be stunned for, I put that inside of this int value right here, and I've used an int value instead of a table because I don't know if maybe there's going to be a script where I have to check it to an int value. And finally, the current time when I'm checking for the stun, I can always access present time with os.clock, and that's how you get the is stunned function. And now for a hitbox, I just got a random part, scaled it, made it invisible, and then named it, saved it as hitbox. I put it inside of my class thing here, and whenever I use an M1, I would just move the hitbox in front of my player character. As I will showcase right here, I have the hitbox, I clone it, and then after the windup, I move the hitbox C-frame in front of my character using this line right here. And the hitbox module is... obviously, we need our duplicates to prevent the hitbox from attacking the same character like 3 times in a row. Because there's how hitboxes works, you know, there's like, you can detect 3 limbs from the same person. You only want to damage them for 1 limb and not damage them for all 3, or else it'll do triple damage. And instead of the usual, just using take damage, we obviously gotta stun the person who gets hit. And finally, the knockback. The knockback is, it is complicated, but for the knockback, there was no simple way for you to do this without making massive bugs. But in a nutshell, I don't expect you to learn how to make a knockback system so soon, because knockback I think it's a doozy. So I have this attachment here called KB, which is just a linear velocity. And linear velocity forces whatever it's affecting to move in a certain direction by that much. And you should watch my acid ball video for the physics behind it. But once a knockback has been called, it performs a heartbeat run service, and it does this weird math. Actually, it's pretty simple math, but physics is hard for most people. So you should watch the acid ball video for greater clarification. And this entire function calculates the physics of the knockback. It looks pretty small because I've made a couple of ragdoll. I made the ragdoll module uses knockback. This is a much more optimized version where I have most of the control. And that's how you make an M1 system in Roblox. Thank you for watching.